The focus of this video is to talk about transformations of our parent functions that we learned about in our previous lesson. So a transformation can be any way that you change a function. You can shift it left and right, up and down. You can reflect it across the x or y axis. You can stretch or shrink vertically, stretch or shrink horizontally. So I'm going to sum that up by saying shifts, reflections, stretches, and or I'm going to use the word compression. It means the same thing as shrinking a function, so compressions. Alright, so those are types of transformations that we would see. The general setup, if we're thinking about y equals f of x being the parent function. Hopefully you've seen f of x used before to denote functions. Here you can see the f and the x, but we have an a, b, h, and k added in there as well. Those letters are representing all of our transformations that could occur to this function. So the a value determines whether the graph has vertically stretched or compressed. So if this a value is greater than 1, then it's going to be a vertical stretch. So like 2, 3, 4, 5, 3 halves would work because it's greater than 1. Anything that's greater than 1 is going to be a vertical stretch. Anything less than 1, but greater than 0. So between 0 and 1, so like a half, a fourth, 2/3, would fall in that category. That's going to be a shrink or a compression. The b value is inside the parentheses. Anything that's inside these parentheses in the f of x part here is going to be affecting horizontal changes in your graph, so along x-axis. The b value is going to represent whether the graph has horizontally stretched or compressed. But everything that we see happening here is going to be opposite of what would make sense in our minds. So if the b value is greater than 1, that's going to be a stretch. No, a shrink. Sorry, see, I messed up. The shrink is going to be greater than 1. Okay? But then the stretch is going to be anything between 0 and 1. So it basically flips. The idea flips there. Alright, the h value inside is negative h, so that just means opposite of what you would think h should do. So it's going to affect whether the graph has shifted to left or right. So a shift to the left would be a plus however many you're shifting. A shift to the right would be a minus however many you're shifting. And if you ever get confused on that, you could type the graph into Desmos and see visually which way it moved. The k value is positive, and it's on the outside of the parentheses, so this is going to be a vertical change, just as the a was, and it's going to be true to its side, so it's going to shift up or down. So if you had a plus 5, that means you're going up 5. A minus 5 would mean down 5. Alright, and then the last thing that we can see happen is a negative multiplied by the function, so like a negative in front of the a, or a negative inside the parentheses, so like a negative in front of this b right here. If the negative's on the outside, you're going to reflect across the x-axis. So remember that the x-axis is running this way. You're going to flip vertically over the x-axis. Since that negative's on the outside, that's a vertical change. And then, on the other hand, the negative inside is going to be a reflection across the y-axis. So here's y-axis. You're flipping horizontally. Okay? Alright, so those are the rules. Now let's apply those rules to 3 examples that are given to us. So we're going to state the parent function and the types of transformations on that function. Then we're going to graph the parent function and the transform function and find the domain and range. We've got a lot to do. So we're going to start with the parent function. And I'm just going to go through each one of these and name the parent function. Example 1 is a quadratic. And the key to that is seeing that squared. So the x is being squared, that's a quadratic. This function is going to be a square root function because of that square root operation. And then our last function has the absolute value bars as the operation, so that's going to be absolute value. All right, going back to example 1. The transformations that we see here, x minus 3, that's a horizontal shift to the right 3. And then a plus 2 on the outside would mean up 2. Let's verify that in Desmos. So I'm going to type in the parent function, which is y equals x squared, to compare to. And I'm going to type in the transform function. Alright, so we can see visually that here's parent function, that if you think about this U shape has been shifted right and up, and I like to compare the actual vertex of each one. So 0, 0 to positive 3, positive 2. That changes x positive 3 units and y positive 2 units. So that verifies our transformations that we came up with. So we're going to graph these two functions on the graph paper given. I'm going to graph the parent function in red. You can use whatever method works best for you in your notes. And then I'm going to do the transform function in blue. So right 3, up 2, and then make that same U shape. Alright, so we found the parent function, transformed function on the graph. Now we need the domain and range of the transform function. We don't need it at the parent function because that was a whole lesson before this. You should already have notes on that. So the domain of this quadratic in blue, it's going left forever, right forever, so domain is all real numbers. And here's a key to any parent function. If domain or range, or both, is all real numbers, then that's going to be true for any transformed version of that function. So every quadratic will have domain of all real numbers. The range, not so much. So the range on the parent function was 0 to infinity. The range on the transform function, well, now we're starting at a y value of 2, touching it, so a bracket on 2 going up to positive infinity. Alright, example number 2. We have a negative on the outside. So I'm going to go back to my notes here. A negative on the outside of the function demonstrates a reflection across the x-axis. So I'm going to write x-axis reflection. Alright, I'm going to skip the 2x minus 6 for a second, and I'm going to do the plus 3. That means that the function has been shifted up 3. And then I want us to look at Desmos for the rest of this. So the 2x minus 6. You may be tempted to say that this has been moved to right 6, but let's see what's actually happening. So here is parent function y equals square root of x, y not 7. Alright, and then y equals negative square root of 2x minus 6, and then a plus 3 on the outside. Alright, so if we look at the starting point here, 0, 0, starting point on this one, of course it's been flipped upside down, so that's why the shape is upside down, it's that reflection. We've been shifted to the right only 3 units, okay? And we've been shifted up 3, which we already said would happen. So the issue with this one, and this is probably the most difficult part of transformations, is that you have to factor out this b value. Notice up here, the b value is separated from x minus h. It's been factored out. So if we think about factoring out a 2, this function would actually be written as 2, parentheses, well, if we divide 2x by 2, we get x. 6 divided by 2 gives us 3, and then a plus 3 on the outside. So what's really happening here is we've moved right 3 units, which is why the graph shows that. And then the 2, remember that's your b value, so go back up to our rules. The b value is a horizontal stretch or shrink. If b is greater than 1, that's a shrink. So 2 is greater than 1, that's going to be a horizontal, I'm just going to use an H, shrink by the amount of 2. So let's sketch the parent function and then our transformed function. Don't worry so much about getting this perfect on your graph, that horizontal shrink. I'm focused more on the starting and stopping points of your graph because that's ultimately what's going to determine your domain and range. So we're going to go right 3 and up 3. We're flipping vertically. So there is a rough sketch of that graph. Domain of this function is going to be 3 to positive infinity. The range is not starting at a point and going up. It's starting at negative infinity and coming up to a point because of that flip. So negative infinity up to the y value of positive 3. And you always do range from low to high. Always do domain from left to right. All right, and then the last example here is absolute value. So I'm going to sketch the parent function real quick. It's that V shape. We've got 3 transformations. We've got an x-axis reflection. We've got right 3. And we've got down 4. So I'm going to go right 3, down 1, 2, 3, 4. And then an x-axis reflection is just going to flip that V upside down. And you could verify that in Desmos if you want to take time now to do that. And then I'm going to go over domain and range real quick. So domain is going to be left forever, right forever, all real numbers. Range starts down forever, and it's going to go up to the highest point, this maximum, which happens at negative 4. So negative infinity up to negative 4 with a bracket. All right, and then the last section of this sheet is working backwards. We are given the parent function's name, the description, and we want to write an equation for the function. So I will do a couple of these with you, and then I'll leave you to do the rest. Let's start with, I'm going to skip A. Let's go to B. Absolute value function. So I'm going to use y equals. You could use f of x, g of x, whatever makes you happy. We're going to use these bars. That operation definitely has to show up to make it absolute value. X will need to go inside. There's a reflection across the y-axis. So remember, reflection across the y-axis is a negative inside the parentheses. So inside the operation. It'll go here. Vertical stretched by 8 will be on the outside. So you're basically just building the function based on the description. All right, and then C, we are looking at square root functions, so make sure you make your square root operation. Vertical compression of 1/2, so that goes out front multiplied by the operation. We're moving right 7, so that would be x minus 7 inside, and then up 9 will be a plus 9 on the outside. I like to close off my square root just to show you that this is not inside. Not necessary. I just saw a college professor do it one time, so I've picked up the habit. All right, and then the sine function. We have a horizontal compression of 2, reflect across the y-axis, up 4, left 4. A lot going on here. I don't have a vertical stretch or shrink. I don't have a reflect across the x-axis, so nothing outside of the operation. So I'm going to go ahead and write sine. In parentheses, I'm going to do a horizontal compression of 2 and a reflection across the y-axis. So I'm going to write negative and 2. That would be like this b here. And then I'm going to open another set of parentheses to keep the x minus h separate. If I'm going left 4, that's going to be opposite of what you would think. So a plus 4. And then up 4 will be a plus 4 on the outside. One other way you can write that is to distribute that negative 2 to what's inside. So y equals sine of negative 2x minus 8, and then a plus 4.